This research deals with the experimental study of the fatigue behavior of welded specimen made of structural steel S355 under combining phase constant amplitude cyclic bending and torsion loading. Three types of weld geometry have been considered: solid specimen without welding, specimen with concave shape welds, and specimen with convex shape welds. Metallographic analysis have been performed on the specimen, analyzing the welded area and the heat affected zone close to the weld. Magnetic particle test method under UV light has also been used prior to testing. Furthermore, the hardness in the welded area and in its surroundings have been measured. The map of the hardness have been obtained for all the three types of joints. The highest hardness is reached in the heat affected region, while the lowest values are located in the base material. The theoretical bending stress concentration factor has also been determined. Fatigue tests have been performed under proportional bending and torsion loading by adopting a stress ratio equal to -1 and 0 for both bending and torsion. Experimental SN curves have been obtained for the two different stress ratios and for the three different welding geometries. The convex welds show the shortest and the solid joint the longest fatigue life, irrespectively of the stress ratio. The experimental crack path have been observed and measured through a microscope equipped with a micrometer. The crack paths are typical of mixed mode fracture, starting perpendicularly to the maximum principal stress and then growing along planes whose orientation is strongly dependent on local stress ahead of the crack tip. The different crack paths obtained for all the examined cases and for the two assumed stress ratios are summarized here. In all cases, the crack starts from the weld toe but propagates differently depending on the weld geometry. Some conclusions: the highest microhardness was found in the heat affected zone. In all cases, the crack starting on one side of the specimen from the weld toe. Different crack paths have been observed. Cracks propagate preferentially inside the heat affected zone where the highest microhardness was found. The shortest fatigue life was recorded for the specimen with the convex weld, while the maximum life for the solid specimens.